Thank you, Jan, and good afternoon. Hello to everyone. I decided to start my talk with a quote that stuck me deeply when I was a university student. It was written in a book. Design is an art, and such as it can be neither imposed nor truly taught. Even if I agree with Professor Nunziata, I also think that science provides us tools to become better designers. And especially when we stand at the intersection between art and science. And I think, of course, LCA is one of these tools because it can help us to make informed and responsible choices. And I also think that the life of an LCA practitioner is rewarding because it is a field that thrives on multidisciplinary thinking. So what can be modeled with LCA was explained by the previous speaker, but let's see in a different way. So based on technical, scientific, and economic knowledge, we can model a technological system, environmental cause and effect relationship, meaning emission of methane impacts the effect on climate change or loss of biodiversity, and market relation. So it is not just energy and emission, but it's also how the system behave and interact. So if you think about a daily life of an LCA practitioner, 9, we need to be market experts for market relationship. And I mean, understand market relationship is very important. Who produce what, and who responds if the demand shifts? Answering this question is crucial because they are shaping the environmental footprint of our choices. Then we need to be environmental scientists for cause and effect relation. And in the daily life, we use LCA software. And inside the LCA software, there are environmental models, also called characterization models. And generally, they are used as is, just pushing a button to calculate the output. But of course, knowing them can help us to understand their assumption and their limitation, and of course, to understand better the outcomes. So, we absolutely need to be HVAC-R engineers to be on track. So, of course, don't take that seriously. What I want to say is that by its nature, LCA requires multidisciplinary approach. So networking is not only an opportunity, but a necessity. This is quite important. And fortunately, I work in a large research group at the Department of Energy, Politecnico di Milano. It's called Renewable Heating and Cooling Laboratory, also called RELAB, with the possibility to extend the collaboration with other departments within the university, such as the Department of Chemistry and Materials or the Department of Environmental Engineering. So to have an holistic approach to the problem. And at RELAB, we test commercial available machines or prototype on using climatic chambers, but we have also the opportunity to work in the characterization of working fluids or mixtures. And also we implement acoustic tests. Going into a little more in detail of LCA analysis, in the plot here, I'm showing the results from a recent study that we conduct. We implement a literature review on electrical-driven heat pumps. In this case, I'm showing the global warming potential results. And the heat pumps are subdivided in 3 clusters: industrial heat pumps in district heating networks, and heat pumps for civil application. I think that similar results you can find if you look at the published environmental product declaration. And as we know, the operational energy phase is the dominant, at least for global warming potential. In this case, it's, and on average, is 95%, but it can be even higher. And so we know that operational energy is something context-specific, and it is influenced by several factors. One of them is, of course, the environmental profile of the electricity that we use to supply the machines. And here is reported a figure taken from Electricity Maps website. And you can see different states and with different colors. So the greener are the countries based on low climate grid, so based on renewable or nuclear. And the darker are based more on fossil fuels. But in this process, of course, we don't have to forget embodied burdens. So the embodied burdens of the components themselves, because they can reach also the 60%, 16% of the total burdens. So in the pie chart here is shown a breakdown of a prototype we've developed. There are 2 pictures, and the prototype is called Adelina. It's an heat pump for non-refurbished building, sorry. So beyond the numbers, the key message is we need to know our product deeply. So not just how they perform, but also what they are made of. And I want to finish my talk with this slide, introducing marginal suppliers. I think this is it is quite tricky point, and because generally when we implement LCA study, we use specific or generic data, but they are average, so calculated based on a specific production volume. But in the designing process, it's important to look at also marginal suppliers, because marginal suppliers are the suppliers able to shift their production if the demand shifts. Therefore, if we put ourselves in the consumer shoes during the purchasing decision, knowing the environmental profile of marginal suppliers is crucial, because they are the ones that providing us the extra quantity that we are asking the market for. So they are shaping the environmental profile of our choices. And so understanding a product's life cycle burden isn't a tick box exercise, is the foundation of a better design. Thank you for the attention.